So we see a metal Y, and she is measuring the diameter of this metal Y using a gauge. What's it called? I forgot the word. Do you remember it? Measuring diameter gauge. I forgot the English word for that. I'm looking for that thing. Caliper, something like. Okay, it's called a screw gauge. Have you seen it in the laboratory or have a chance to use it? Oh yeah, it is supposed to be used in the first topic about measurement in the school. And next time I'll send you some document to practice doing the reading of this screw gauge. Okay, screw this thing. It is used to measure the size, very small object, even the thickness of our hair. And at the other end of this, the two metal wire, of course, they hang some weight there to measure the extension. Here, this is the ruler. So there's a lot of weight down here to here, the clamp holding the wire. Yeah. So that by this experiment, we can calculate the stress, which is the force, which is the total weight adding to this wire, and divide the cross-sectional area. The cross-sectional area is calculated by pi times the square radius. So she measured the diameter before using the screw gauge to calculate the cross-sectional area. And then the stress, again, the stress is force over area. The force is the weight. And lastly, the string. To find the string, we need to measure the extension of the wire and then take the ratio between that extension and the natural length to get the string, which is how many percent, like 10% of the extension. And the ratio between the stress and the string will be the Young modulus. And we can see it's not very clear. Here, the two coincide lines on the glider here and the ruler. So extension, because the weight 2 is not enough, so we haven't seen a significant extension, meaning a very, very tiny extension. So we need to add more weight to this experiment. She added another 100 grams, adding 500 grams. The extension is 1.4 millimeter when she added 500 grams of weight. Okay, difficult experiment. Okay, the 0 on the vernier scale, meaning the glider, the 0 here, passes the 1 millimeter. So the extension is a little bit greater than 0.1 millimeter. But how many? 0.13, 0.14, or 0.16 or something. Okay. The next step, I taught you this thing about what's it called? Caliper, like in the first lesson, right? The next thing, we need to find the two lines that are on the same line, coincident with each other. For example, this one, the line here on the left is on the same position with the line on the right on the vernier scale here. Yeah, this line. Do you see it? Hello? Yeah. So 0.1, 2, 3, 4, 5. According to my reading, it is, so the extension is 0.15 according to my reading. But she told us in the video that is 1.4, meaning she chose this point. The coincidence. Like, we need to look very carefully. This is probably they are on the same position better than the next line here. The first line that lines up here, the first line here, 4. The fourth line, 1, 2, 3, 4. That lines up with the fixed line here on the main scale, and therefore the extension is 1 millimeter. I will send you some more questions to practice about reading the value on a caliper. This one, caliper, do some reading. So that is the method of doing this experiment about the Young modulus. Ultimate tensile strength. E is the elastic limit. E here, limit. Overcoming the point E, the object cannot restore its original form, original shape. Limit of elasticity, elastic limit. And beyond this point, the Y will experience plastic deformation, permanent deformation. Y1 and Y2 are yield points where there is a rapid extension. And UTS here, maximum stress, is the ultimate tensile strain, the maximum breaking stress that can be applied to the Y, meaning the Y will break when the force is too big at this point. Stress here is the force over area, force over area. So when the force surpasses this point, the string breaks. Okay,